servant. Servant Haskell. Um, and as I recall, this is like a family of libraries that exist. Um, what can I do here? That's a lot better. Okay, so um, whatever. I'll keep trying to find my chord as I go, but I think it's gone somewhere. But anyways, so um, the I'm not going to go through the actual tutorial and all of that just because that has been it's been quite some time, and you know I would like to get something cool done in 2 hours. So you know I'm sure I could go through get a very good understanding of like to what to wait why F I don't get it. Um, get a very good understanding of like how to build like a web server. But we ultimately know like that a web server is basically just a you know a set of routes that we can hit. Um, and so I'm gonna try and be a little bit what's a quick way to do this? Yeah, Haskell API client 5 minutes. Um, so yeah, we're basically just writing something like this, where we're basically saying we have three routes, right? If I remember this combinator correctly, this is just like a way to combine routes into a coherent API. Um, and so I believe capture gets a route or sorry a another part of the path, and then this is I think it always ends off if I remember correctly with what the type of the what the type of the payload is if I remember correctly. Let's see. Okay, so maybe this is serve an example that we can kind of quickly pull from. Um, so I just want to get something like basic started here. Can we even just work with this? Well, you know what? Also, too, I should probably get an environment set up just to begin with. So what I'm going to do is I'm going to go into code learning, and then we're just going to make a new directory servant example. Please remind me, and I'll upload whatever source code we create here. Um, and for the purposes of this demonstration, I'm just gonna like what I figure is best is I will just use Cabal. I will not use Nix. The one case in which I will use Nix is just to set up the kind of you know Cabal environment. And so I'm just gonna say Cabal and GHC. So now I have Cabal install. My bad. So I now have Cabal on my path. Part of the reason I'm doing that, to be honest, is because I'm also on NixOS, which makes it very much a pain to not use Nix. Or it's not necessarily a huge pain, but I don't really do that. And so I guess I want to try and just see like could we just say servant server. Cool. So I can turn this off. I don't need that right now. Don't need that right now. Let's say cabal init. Oh, right, I haven't gotten the cabal install in my environment. And then GHC. what GHC version are we using? 9.10. Okay, so I'll just say cabal and knit. I'm going to make it executable. It's going to be sure. Just going to accept defaults for just about everything. And now we have a very minimal minimal example set up. So let's get to work on this. So if I remember correctly, I remember that roughly what servant is you would say there was a run function. I think you say like what port you want to run it on, and then your application or something like that. So I am going to oh, I also need to change the what we are streaming. We are not doing that anymore. Let me just edit this. Go live notification. Servant building a web server in Haskell, or I'll just say web server. Building a web server. Yeah. Okay. And so yeah, so what I'm gonna do is I'm just gonna look at like what does Google tell me about this? Google is like really I think all I will ever need. I mean, there's obviously nicer things that will be coming in the future, like better improvements to Haskell language server, making it easier to basically be a local Google. But Google's awesome because I can just say, even like for example, run, and I want to find it from the set of. Can I not say servant? No, servant. Package servant. Servant. Server. Huh. Oh, that's. Or I'm thinking. I might be thinking. I might be thinking of the run application or from warp or way. So this is basically just a way to run any as I understand, like a number of web server libraries in Haskell are just built off of warp and way. What do they stand for? I think it's a web application interface, and then I do forget what warp stands for, but actually I think I can look at the contents. Oh, okay. Do. But yeah, so I mean, and like basically, what's important to understand, like I think most people know what a port is. I mean, port just being like the the number the basically the address where you're running your server, such as localhost 8080. 8080 would be the port, but the application, maybe we can see how it's a little bit more of a generic thing. I'm gonna put on some music, by the way. I forgot about music. And let's just do lo-fi, something nice and yeah, slow living, all nighter. Let's do that. So yeah, okay. I already feel a million times smarter, even though that's not the case. But or million times a zero. But anyways, so basically, a web application is something which takes a request. Um, it also provides a handler for the response, um, and gives a response received. Oh, hello, yo, crap. Uh, Peace out, brother. Sweet. Okay. Um, so, anyways, it's just basically basically it looks like a bracket. Even yeah, it's literally a bracket type of thing for cleaning up the response. Right. That's why we have this sort of second function here. Um, but yeah, we don't really actually interface with that too much. Um, anyways, so Google. Let's just go to servant. I'm trying to remember. I think this was like the API types, but then you want to actually use servant server as the first thing I want to look into for getting like a basic thing set up is just is this servant server. Um, and again, I haven't looked at this in like many years. Um, so yeah, okay. Here's what we want to do. So exactly, um, this is the application object. This is the application type that we were looking at before, right? And if I click on this, I can see that it is literally basically just a re-export the from warp or from network.way. Um, right. So basically, serve takes a proxy to an API, or a proxy of an API, a server of that same API type, and provides us with an application. So that means, okay, yeah, this is exactly what I'm looking for. So I can basically just say here, what I want to do is exactly this. So I'm going to need to import network dot way dot handler dot warp, um, and yeah, I'm gonna call that warp. Make it qualified, just so it's really obvious what I'm doing. Um, and then yeah, that looks pretty straightforward. So now I can also shorten this. So it's just warp.run. I could also make it shorter if I really wanted to, but like that's a little bit nicer of a style to write in, at least for my tastes. And so right, we have built this application. It's really just it looks like and I'm now remembering that it's basically just a top level constant in the sense that a server should be a constant. Sorry, an application or an API. I guess it makes sense as a constant. Um, and so I guess I forgot about this piece, and I don't think I would have remembered this even at the time, or I would have been understanding of this at the time. But proxy is an interesting type, and the reason for that is because it's a phantom type. So all of these have the same um, in a sense, unknowledgeable sense, these all have the same value. They're all the same at the type, sorry, at the value level. What makes these different is that we are just asserting that these are just some other type, right? Even though they look the exact same, they are some other type. And so the point of this is not very clear when you start. I definitely was not very clear on it when I started. But I've actually since built applications that use proxy, or kind of more recently a better approach to type applications. But this all started with proxy, to my understanding. And it's basically just a nice way to pass around a type level information. And well, when would you need to pass around type level information? When you're doing something really complex or fancy. So I'll leave that just as an exercise to the reader. Yeah, let's go check the chat. What do we got here? Oh, and I don't even know where the chat is. Yes, I need Twitch training. I mean, honestly, now that I'm back from vacation, um, yeah, I need some Twitch training. Even too, I think like we should start doing dual streaming. But that's a whole other thing. Uh, like where we and also whatever. I'm not gonna boil the ocean um today. Just gonna give myself a smack on the wrist for the speaking corporate. Um, but yeah, so all we are doing here is like there's nothing like it looks like we are doing nothing here. But if I had to take a guess, this is in some way useful to the serve function. And I'm kind of curious now, actually, if it's not going to be too insane. We okay. So I guess we pass along this type of information. We continue passing it along. Continue passing it along. Do we actually do anything with it here? We say p in hoist server with context. Yeah. Okay. No, it's going to be a while before we actually like get to the source of like how servant uses um the the proxy. But I imagine it's very interesting, as I've never even like in all the time that I've used Haskell, I don't think I've seen as a library that has like kind of wowed me as much as Servant. But I'll take the guess at a high level that this proxy allows us to basically take this type and um, convert it into an actual runnable application. So yeah, and this is also a little bit fancy too. Um, what can we say quickly about this? I don't know. I don't think it's important for me to understand at this point. I think if I remember correctly that this just means we are able to use a number of different types to define what our server is built on. Type is just a very generic, like literally the most generic thing. It is just pretty much any type can fit in there. And I'm sure someone who works on GHC can tell me the difference between type, star, if there's still a difference between star and type, and if there's a difference between type and polymorphic A, for example. But anyways, so our API, we don't even have our server here. So okay, so um, and we're gonna convert this. Like I'm not gonna make this a video about me just copy pasting because that's not much better than that's not no different than just having Claude do the whole thing. Um, I'm sure Claude can figure this out, and I'm actually curious at the end to see if Claude can one shot what we're gonna build here. It probably can. But yeah, so I'm trying to remember now. This server, my API. Um, I'm just trying to remember, like, what is the type? it'd be really nice if the example had just like the type of post book as well, because the reason is I remember there's like a case where I believe there's a handler type, if I remember correctly. Route, no. You can also put in middleware. Let's see. Okay, so and also too, whenever I'm on a hackage URL, I have the ability to just press S, um, not Control S, but just S, and I can just search for whatever I want to find. And so I believe this is what I want to do, or at least how I would have done it last time. Is I want to find a handler. Um, yeah, I think that makes sense. And what I'll say is that I'm gonna try that, and then if it doesn't type check, then I know that there's a reason for that not type checking. Um, so I'm just gonna say actually, and I'll just say pure. That'd be another way to do this. And I'm gonna say that just gonna add in list all books is a handler of that, which I will see if that's wrong. Um, oops, no. Okay, I'm just gonna so it looks like book is a type even, which I don't have defined, and I guess I mean book probably can be whatever arbitrary type we come up with. So I'll just even make a fake type of a book here. Data is a book constructed with a book, and it's a record where we have the name. That that's just some text. So I'm going to need to import text. So I'm going to say, I don't know why I'm spacing that out. I'm going to qualify it as well, and I'll say data.text as t, just so I know where it's coming from. And then description is also a t.text. We're going to need to import all of where this comes from, but we'll figure that out. And the next thing that at least that's on my mind. I don't necessarily have to do it next, but I'm gonna want to. I guess I said to add informative comments. That's okay. I'm going to need to add servant server to my build depends. Let's see if this works. And let's try a shell here. I probably don't even have Cabal set up in this environment. So again, I'm just going to do the same command. I'm going to say just Cabal run and just see what complains. Okay. So and again, like I would normally okay. Cannot find LZ. Oh, okay. Well, this is probably just because I'm on NixOS, but if I go no, I want gold. So that's just the linker. That's just the linker program. probably honestly, it's probably just zlib that I need. We'll just do this the old-fashioned way. Just see how this goes. Haskell. No, that's not what I want. Oh, okay, there we go. So yeah, it was just zlib was missing. Um, zlib's like one of the first things you would install if you're on Ubuntu. Um, and I believe it's just for compression, if I remember correctly. Anyways, we have a parse error. And what was the parse error? Postbook. Oh yeah, because we didn't actually write a proper function here. So we're also just going to say that is right. We're also just going to say that that is whatever type for now. So we're going to need another package here called text. In this case, it knows of that package. It's just hidden. So it's going to say hidden package text. So we can just literally directly take this one here. We could even specify the version if we wanted. If I do remember correctly, it would be just saying 2.13 here. I'll do that just for the fun of it. And yeah, I'm also going to need warp equal to 3.4.12. And I'm going to check the chat. Um, oh, okay, we have promotion here. That's great. um, anyways, so now that I think that's all the packages that we should need, at least for getting a very basic thing set up. Oh, and then yeah, we're gonna need to just get this set up because application. Where does that come from? That's gonna come from I believe warp as well, or unless it's probably actually it'd be from network.way. So I'm gonna say import qualified network.way. And I'll add in too like a quick note about how Haskell modules work because I actually saw someone in the Reddit community today that was having some issues with it. Um, and like basically, what you know is that like if I see this network.way, I know that in the actual contents of the folder in the package that there's like a network slash way.hs that exists. And you can export things as well. There's nothing. So you can re-export. You can have packages or modules that re-export other packages. Like for example, where is it here? We had some re-exports, useful re-exports, right? And this is just from somewhere. But we could also like while we could. So what this means is that we could import proxy from servant. But if we were to look quickly at Google, and I just happen to know this, we could import proxy from data.proxy. So, a lot of types are reused from basic packages that are now just re-exported through servant. So that's what we're doing there. And then application. This is going to complain unless we say way.application proxy. So I'm going to prove this, I'm just going to say import data.proxy. And there's going to be literally one thing that we import, which is proxy, the type. We're not even going to, I don't think, actually, well, no, we are going to import the data constructor as well. So that would be the syntax there. handler. I believe handler was from servant.server. Yeah, servant.server. And again, we see there, right? Handler is in two modules, and so like I'm gonna make a guess that the handler here is where it's actually defined, and that this is just a re-export. Um, and so for not really any reason, besides, yeah, there we go. It's just directly from there. So for no good reason besides just like I would like to import from servant.server, I'm going to import from servant.server. But again, I could choose to import from the re-export or from the base module. And so I think like Haskell modules are very nice because you know they're very definitive for how they work. I really am not a fan of Python where I still don't understand how the module system works in Python fully. I kind of have a rough understanding, but also Python doesn't really inspire me to learn more about its system. So servant.server, servant.handler, servant.handler. I think that should be. Oh, and then we just don't have a way. Okay. So way equal to 3.2.4. And JSON is not in scope. Okay, yeah, so cool. We're actually starting to get more interesting errors, anyways. And I think, I mean, it'd be good to just say like how do you solve these? Because I mean, it's really easy in a way. Um, like the strategy to solve this is really straightforward. So I'm just gonna go to here, and I'm gonna search JSON. Okay. Huh. I would have thought actually, because there's what is it? No, it's not text. There's like format, content types. I think it was. Accept. Yeah, this is like a little while ago that I'm trying to remember this now. But we have this accept where it's content types. Is that okay? This is where it is. So that's a bit of luck that I kind of found that. How would I actually find that? Maybe, hopefully, hopefully there's a very clear um, tutorial to go along with it. And there's like Servant really does have a lot of tutorials, so I'm sure if let's say you're going through Servant for the first time, you would happen upon that. I mean, that's how I even knew about it. I didn't have just some lucky search skills. Um, and so yeah, just good tutorials. And so like um, this is just a type of format that is supported. So this is the accept class where we are representing MIME types. And I think also like one thing I wanted to one of the reasons I've always wanted to do servant as a good stream to do is that like while like I have mixed feelings about the fact that I started with servant because um it's like the most complicated library I've used. But also at the same time, it's like the best demonstration of like what could be, I suppose. Um, and it's very clear how they take for like the HTTP format. Um, how they take this kind of raw. Is raw? How do I do that again? Say raw. I can't think of how to see it raw. I know there's a way. but like there's a very clear format to what what HTTP request and response is, and all servant does is basically create a great way to turn that into a typed application, right? So we of course have our URL. Um, let me get an HTTP request example. Yeah, perfect. So we're always going to have like what is our our method. We're going to have like what server or sorry what is the route we're hitting, what is the version of HTTP we're using. I think it's like nearly always 1.1. Never given much more thought to that. What are the headers that we have? Um, and the headers have like kind of their own specifics of what is a valid header, right? And that's all that a type is, and I think that's where like I kind of really internalize like what a type is that a type is like a definitively valid format. If you can create the type, or you should at least know if you're doing things right, that um, it is correct, right? It's correct by construction, so to speak. I guess we have an empty line in HTTP. I didn't know that. Questioning that, but I trust this, I guess. But you know what? The thing is, like, I would never have need to think about this because um, I'm just providing a request type, or sorry, even I guess a request or response type to servant, and then it's going to turn it into the um, the raw text that hopefully fits the right format. And so, right, it's just a nice one-to-one mapping of valid format to a Haskell type, and yeah, that's a good way to explain it. And where the heck was I? Oh yeah, we were talking about JSON. So this is from servant. Oh, I'm also going to want to import, not import. I'm also going to want to depend on servant, and I want to see if that gives me a better warning, or better error. Um, okay, if I do, let's see this. If I say import servant dot API. Okay, so it found it. I'm curious now what it will say for when I don't have it. Yeah, so it knows that like at this point, now that I have this module in my file, even though I'm not importing anything from it, it knows that I perhaps want to import JSON from the servant.api file. And so also too, like just to drive home the point, if I was to be in the right package, then I would have found the JSON type. And I think that's just kind of a bit of knowledge to be had. Is that you know if I remember correctly, you really strongly need to use servant and servant API. Sorry, servant and servant server. Or like kind of they just automatically go together. So, anyways, so I think that's enough elaboration there. And now I want to say, um, I now need to add a language extension, and that language extension being to um, to allow for data kinds. So what does data kinds mean? And this is like, especially whenever we see something like an extension, we know we are getting into um, um, something which is really specific to Haskell. At least for the most part. There are cases where it's like that's not true, but for the most part, these are like kind of more experimental, but very very high quality experimental type language features. So, and I'm doing great. How about yourself? The Haskell is going great. It's going it's going a type of way. Um, but yeah. Anyways, and so now, okay, we want to say post. Perhaps use port. So maybe okay, things we misspelled it. Add post to the import list of servant.api. I'm not sure what this is, so I'm curious. I have the thing here. Just search it like this. Post. Oh, I'm so stupid. I thought it was a content type. Clearly, I've been on vacation. But yeah, so we're gonna also want to import um, post for our post requests. Right. So this is now saying, what does this read as? This is a get request, and this is a post request. Right. And so these both have a way of serializing um, to an HTTP request, of course. Okay, cool. Oh yeah, and then this illegal operator. Where does this come from? Is this must be servant API.sub. So I think it's like called API.sub because it's like a sub route. Is my intuition on it. So if I want to import this as the lone thing, I need to add another set of brackets because it's infix or a symbol um, as opposed to if I was to add in func, right? It's just something there. I'm probably also going to want to import. I think it was this here, and so that is so basically right. Like so, kind of like what does this mean, right? This is like if you know Haskell, you'll know that this looks just like the option operator or monad plus, where we can kind of choose between different routes or choose between different options that we are combining, and this is combining into one singular route, right? And so I believe that this. I'm actually curious if this will be clear to us. Because I believe this is somehow enforcing. Interesting, right? If I remember correctly, and this is just a pure pull from memory, that I think we end off with a verb. I think all of these requests are always going to end off with a verb. Um, yeah, and they I believe they start with the path always. So that's why they're calling it path here, I guess. The contain API second argument can be found under. Okay. Um, and request body. You know what? Honestly, at this point, well, no. How many pages of this? Oof. Let's just do get post. We have, and I think now we're just gonna have complaints. Oh, okay, fair enough. Did make an assumption there. Where does that come from? Servant.api.alternative. Okay, that makes sense. So this is literally just the union of two APIs. Um, First takes precedence in case of overlap. So like in the same way that like if we had, the alternative operator, then the first one to succeed, right? The first one to succeed from left to right is always going to run. And so if it basically reads as, if we did not match on this route, we match on the second route. So yeah. Okay. Let's see. Servant.api. Just checking. Can we hear the music at the moment? Okay. Um. Cool. So now we just have a couple complaints. Basically, just a couple complaints about. We have our we still have to import a couple random types from the library, but mainly we're just saying a legal operator. So this is another extension that Haskell has added since Haskell 98, and it is basically just, what is this, to have type operators. Yeah, type operators. So what this means is that we are basically at a type level. Like these are type level functions, right? So what is like a function? And this sounds scary, but like a function, if we remember, is basically just a thing which it's a name, right? Or lambda more specifically, but usually it has a name of f here, and it's just something which takes an arg and um, returns something else, right? It returns, basically anything from A to B is a function. Um, but the thing is, we can kind of like get really fancy with this, right? And again, like, well, first off, what does this mean that we have like from A to B? It just means that we are going to take as input x, and we are going to return some b, and b is defined by whatever x plus one is. And so here we can actually see, just even from the logic of it, we know that a is or b is going to be the same thing as a, and that a is actually probably just an int, right? So it's actually pretty straightforward. There's still like a term level that is existing, um, but you know we are advanced developers and we want to get really crazy and do some extra stuff. Well, now we can kind of focus our energy inside of these brackets, and we can say, we can have a type of a function f, right? And what f does, um, f is basically something which takes a type and returns a type two, or a second type. So that is, you know, that is just the same thing, but at a different level, at a different level of abstraction. And so, what does that actually mean for us? It just means that we have a really clean interface to build an API, right? We can build this API because of these nice little type operators, these nice little functions that are operating at a type level. Oh, and the data kinds aspect is kind of funny too, because, well, we just basically are able to say this exact term, right? This is just a term, in the same way. And I don't know if this actually works for servant here, but I can also just say 12, right? This is a term. This is a real concrete value, and we're just saying that we can now have concrete values at a type level. Um, so, like, what does that actually mean? It means that we basically said um, that we have to demand that the case is books, right? And so like we don't even need to use data kinds here. It kind of, I mean, maybe in Servant we do, but in theory we actually don't need to. We could instead say books, or books, whatever, and keep it at a type level. But then we just have this basic type like books, those books, um, where it has one value, right? And this is the goal that we were trying to do with types, anyways. Is like this new type of books is a lot different from a string, where a string can be whatever random crap um, inside whatever length, right? And so, um, whereas instead of being any million things, is one specific value, right? And so now what's cool about data kinds is that without even adding in this other kind of boilerplate, we can, for example, do something like this, where we just say if the input does not match our type, which is basically just the literal word of books, reject it. And right there's no, and this is really important to think about from a security perspective. Like, maybe not with the exact API that we have here, but what happens with the security hole is that someone just accidentally created behavior, right? As someone accidentally programmed in behavior that they never meant to. So, like, let's say, instead, all we're doing is saying, I want this to be a string. Okay, well, now at some point, we're going to have a function which checks is string equal to books, right? Um, but we don't want to leave that to chance. We don't want to allow for ourselves to make a mistake, or for people on our team to make that kind of mistake that could lead to security holes. Anyways, and that's like, it sounds funny, but like really any unintended behavior of an application can result in one little piece that results in a larger security hole. Yeah. Okay. So, anyways, without further ado, did I do that? I did. Okay. So now let's see. Does this run? Right. Okay. So I can just say serve. And I've kind of purposely done this with my imports too, because I want it to be clear when we look at this that like this is something that we've defined locally here. Oh yeah, servant. And like, where is this coming from? Because as we can see, there are multiple different modules, and okay. So I guess it's saying that the type of book needs to be to an instance of to JSON. So I'm not sure how exactly, or where exactly that's defined, but clearly it is defined somewhere um, in in um, in servant, that when we have this this sort of look here, where we have either a get or a post, which has a content type with the resulting with the result type. Actually, let me reword that, because that was a lot to say, and it often is the case with Haskell. Um, this get is a constructor which takes a type level list, which, forget about the type level aspect for now, but it takes a list of what content types it will allow, um, right, or the MIME types more specifically, and then what is the result of what is the resulting type? So, um, yeah, what is the resulting type? And so let's actually look at this. Nice. Um, so if we look at get, oh, okay, and this is in. So it's a verb. Okay, a verb. And a verb. Okay, exactly. A verb is basically um, what the actual method is. Um, so, for example, get what the status code is. I don't think and that's kind of abstracted away from us because we just have those hard coded for the type of get. Um, we have a sorry, and then we have the content types, which can be, I guess, anything. Interestingly enough, um, but they probably, I believe later on uh, they are constrained to something that takes has an instance of accept. So, and then finally, some result type that we are creating. So this route is going to return and give a list of books. So that's going to end up being basically this here, right? And then we are going to say that this is a handler which returns a book. Handler is just a monad, um, which we will talk about more. Okay, cool. And we could not match type book with with we could not match type book with the actual type. Okay, so I guess in this case I'm just gonna say pure book. See and test this. Oh yeah, and it's complaining about the to JSON instance. The easiest way to do this is just to say deriving generic. Um, what this does for us is that we basically can get at the type information. So now we can programmatically get at name, like whether this is name or namee, whether this is description or description, and do something with that. But we also don't even need to do anything with that because someone else has already said how to derive JSON for anything that has an instance of generic. So because we have deriving generic, we can now say instance of to JSON of book. And I'm also just going to add in instance of from JSON book. And there's fancier ways to do that. I don't really care for them. And I'm going to need another language extension, which is just that derive generic. So this is going to automatically turn this into, it's going to automatically write that code for me based on my Haskell type, and that will always work. And so because that's always going to work, I can always turn whatever I want into JSON pretty easily and round trip it very well. So next, it's not complaining that I haven't imported JSON or data.ason. I'm going to call it JSON A. Oh yeah, and we haven't added it to our build depends. Um, hmm. Well said. Okay. So now we're building. Oh yeah, and I need to import ghc.generics. So again, I could find that from Google. I just know that off the top of my head. can't match accepted type book with actual type A, pure book. Oh yeah, because I'm saying that it's taking a book in. Oh, I think what it's saying here. I'm curious about this. I think this was scared me back in the day. Yeah, is that the actual source? If we look at the source code of this and we really zoom in, it's just the same as saying, um, for example, we can write something like this. So we can say, pardon me, we can say instance, or sorry, not instance, identity A equals identity A, where identity is a type and identity is also a data constructor. I don't like that. I'll be honest about Haskell. I kind of wish that was not the case because I think it's a little bit confusing when you're trying to talk about things. But it's also pretty nice that you have that option, I guess. Um, so in the same way, that's what we're doing here. We have our fancy uh, language extension, which allows us to use symbols as type operators, um, and we can use them exactly as such. So this is just a type. Sorry, this is a type constructor. This is a data constructor. And so I have not. It's gonna look a little funny. I don't even know how I'm gonna do this actually, but I think I would say, is that valid? Yeah, I don't know. Oh, okay, I guess that works. Um, anyways, okay, so I am just gonna say this is a list of an empty list of books just for now. Maybe I'll even put in one book. So it's a book where we're gonna say the name of the book is um, um, uh, um, I hope we don't get copyright on that, but or I'll say so we don't get copyright. I will say Carrie, which is a great book, great horror book by Stephen King. And the description is a good read. This is definitely taking a second. Just gonna go to the chat for a second. Right. Huh. So while that loads, which is just gonna take a second, I am just gonna zoom back out and look at what is the handler, anyways. So the handler is basically just a very simple accept T. So at any point, right? And this is what is this? This is a new type. Yeah, so I guess it does have its um, own behavior or whatnot. But we can say run handler. Yeah, I guess we could say run handler. Or do we say run handler anywhere? I guess we don't need to. I believe they would call that. So that means that we can basically say how would we throw an error? And this monad error applies to. Okay, so basically this is probably just it. I mean, um, right? If what we have here is a do block, or like a basically a monadic function, so we can write it as a do block, and we can just say, for example, throw error, um, say four error 303 or error 400. So this is valid, and will work. Dang, what is taking so long? Um, so I wonder too, like let's dive in a bit of like request body. I mean, request body obviously being a core piece. I'm also curious about like query params. True. Okay, so you could just say, I guess it's just the same type of combinator. You could just say that, like, for example, I'm just gonna close that for now. We could just say that this also takes a query param of authors, which is going to just be plain text. Um, and so it's really that simple, and that's what's like really nice about the servant API. Um, right. Oh, and I forgot this piece. Um, but I know too that if I add the query params, then I believe that this will become. I believe that this like just literally builds this into being a um an argument for post book, right? So um this I guess this type level, um this value level um option function, or route option function, is going to match up to what we have here, right? So like, for example, it would not make sense to say do this because um, we haven't implemented a third option. So yeah, um, Oh, and then one more language extension I'm going to add in here is overloaded strings. So yeah, this is now complaining that you have tried to build something which doesn't like you know you have this does not line up. You haven't defined a um, you haven't defined any actual API type for this last piece here. So if we go back and pretty much type book with text. Um, oh, and I think this is actually what I was saying here about that. I believe that this becomes an argument as well for the second um, one. So this would be now. Oh, or maybe. Okay, well, first off, what I'm going to try doing is I'll just see if I misunderstood something about this query params. Okay, so I'm probably I seem to be misunderstanding something about the query params aspect. Huh. I guess like maybe the type was actually a list of text because which feels odd unless maybe I'm thinking query param is more what I have in mind. I'm curious though. What did I have here? I query params. Okay, I'm curious now. Oh, it may be text. Oh. Oh, wait, I would have these reversed. Sorry, it would be actually in my type. I was thinking. I don't know why I was thinking that this was the first thing I'm going to see. This doesn't seem to return anything, whereas this seems to say, um, give me my first argument being text. So and I'm gonna prove that. um, by the type error. Oh, still need to reverse that. Oh, and I guess that's not going to complain because why would it? I haven't. I said it can be anything, and I didn't use it, so that's like going to allow for that. And yes, it is a maybe text. So I guess whenever it is whenever the query parameter, a query parameter is something that which may exist. Um, it'd be nice though, like if they could show in the documentation like that this is exactly what it will result in. Um, but basically, I guess what this means is that we probably, and if I understand Servant's internals well enough, there's probably some type level function, right, or type family type level function, which is converting from a query param author's text to a maybe text, right? So we have some type family. How do we write a type family again? Um, I guess that's how we roughly write it. Maybe I thought there was a different way to write it, but whatever. It doesn't really matter. Um, I mean, and what that's going to look like is somewhere in the code, we have just simply defined that a query param, some string, um, and the associated type is just going to result in a maybe a. And so we've just defined at some type level that we are just going to change the wrapper around this a, right? So we're first calling it a query param, and then how do we actually use a query param? Well, we just convert that concept into a maybe a. And what that's going to mean is that we are going to like actually have some logic somewhere. Servant is going to have some logic somewhere, which is and so actually maybe we don't even need it. Maybe they don't even need the type family. Um, they're gonna perform some logic, which is going to provide a maybe text. And so what that will be is just really a simple parse of the URL of the URI to see does that exist. Right. So um, yeah, yes, yes, Haskell would definitely help. Yeah, I'll say too. It's kind of funny how how easy this was to do. This has clearly worked. We've clearly passed the the type checking phase, and now we just have something which is a server. Right, so there's a full on server. Once we have this up and running, which I don't know why it's taking so long, but I'm curious now. Hmm. So yeah, I mean we just built a pretty awesome server. We're just waiting for it to compile. I mean, and unfortunately, that's a fact of Haskell. It is like slow to compile. But honestly, I'd much rather know that it works, or rather, don't get my hopes up. You know, tell me if I'm an idiot um, before I think I have working code. And then you know what, the fact that I think the fact that it takes this much time to compile, um, is honestly okay because you know I'm not gonna wait for it to compile at least at this length that many times, right? The first step that happens is the type checker, and so basically when we get to this step, which this is usually a lot quicker, um, then you know it's not a bad risk to take. But I'm curious, like if I do no, but why would I do that? So was it Haskell.compiler GHC? I'm almost curious if like 810 is going to be quicker. And then Cabal install. Oh, okay. Well, I don't even know why they'd have it then. I don't know, 9. I said I was not going to do anything with Nix, but I think at this point I've kind of proven that we can do it without Nix. And so I'm probably just not set up my thing very well. And so if I'm like feeling lazy about setting up a Nix project, I can just very simply um, do this. Say Dixel Cabal to Nix. And I can say, give me a shell.nix. Um, wait, no, I want that's my default.nix. I could make a shell with passing the shell argument, but I don't really want to do that here. And I think I could just literally go nix build default.nix. Doesn't have. Oh, no, I need. Well, you know what? Maybe I will. I will just for the sake of speed here. And we'll say next shell. Crap, I did another wrong one. Let me say shell.next. Now I can just say next shell because I have a shell.next. And I almost wonder if it's like maybe how I don't know. For all I know, it could be something to do with the way I've included zlib. I didn't really give that too much thought. So let's see here. If I do cabal run now, is that going to be quicker? Oh, right. And I haven't said shell p cabal install cabal run. I don't even know if I want to do that. What the heck? For the heck of it, I'm just going to, as I'm incredibly impatient, nix run cabal to nix dash dash. No, wait. And I'm trying to remember how I do this, but like there was a release.nix or nix for Haskell, something like that. Guess I could do that. Okay, so this was faster. And see, okay, that is interesting. Okay, I'm just gonna see if I can do it from memory. Something like it's bothering me. I know where I can figure this out. This is literally what I'm looking for. Oh my gosh. I thought it might have been call package, but I wasn't sure. And I've never remembered this because I guess I didn't need to remember it. Okay. Now I can just say Nix build. Oh yeah, Nix build. I don't know what the heck is going on. Okay. There we go. I don't know why that's taking so long. Oh, it's is it running? Oh, I think that's just verbose. Okay, so anyways, I have a result, and I can go into this result here. Um, yeah. Um, we have here? We have to serve an example. So, oh, it's already in use. Okay, maybe that's what I was seeing before. It's already in use. Let's see. Netstat to check what oh so just checking what ports we have open or what are in use. So it looks like we are directly using 8080. We have hard coded in 8080. You know what? That's kind of annoying. Why don't I just? I've always wondered, can I just do this? And the answer is yes. I can just do this. I'm gonna say what is it? Get line, I think. I'm gonna call strip on get line. Strip and then read. Let's see if that works. Oh, nix build release.nix. Not t.strip. Yes, that's what I want. I don't care. For now, I'm just gonna tell myself that I'm gonna do this properly, and then we'll make that a little cuter later. That is a good point. And this is going to be a int, right? I would have thought this would have complained if I didn't specify warp. Is a port not okay? Why would that not automatically know that then? I thought that would infer that it's an int, but maybe there's something I'm overlooking. Oh yeah, and oh, because I'm not passing the port, you dummy. And so now that should infer what type I want, anyways. Okay, cool. So I'm gonna say run result bin serve an example. It's now I haven't done anything very cute yet, but I can now say port 8081. I guess let's curl this and see localhost 8081. What do I actually do in here? So let's say, oh yeah, get books. Great, perfect. So we have a working API. It's nice and it's not cute, but it works. Um, and yeah. Um, I'd say we did that in like okay time. For the heck of it, you know what? Honestly, since we even have like the server set up, and honestly, like I feel like the most time consuming thing of Haskell. No, it's not true. When you get really good, the most time consuming thing of Haskell is that you have to write code. You know, and I see we're talking about once you're faster writing Haskell. Um, it's true. I mean, once you like start writing a lot of Haskell, what what is so concisely avoiding boilerplate? Like, you know, if you're writing something in JavaScript, Python, whatever, and you want to do something like you want to have very controlled behavior, you end up with so much boilerplate to make it happen. And then in Haskell, it's like 3 lines, and you actually, you know, you start moving and thinking so fast with Haskell that those 3 lines feel cumbersome, And I don't think we'll ever be happy with how good Haskell could be. Which is why people write language extensions so that they don't have to write 3 lines. Like for example, this being a language extension that I can just use generic. Someone wrote generic, so we never have to think about the basic structure of this again. Like we can all see that this is obviously just a JSON object with 2 fields. Um, it's very clear how that maps. So someone just wrote that, and I never need to think about that again. Or did I? Never did I need to. But yeah, I'm kind of curious because I never actually looked at this when I was. Yeah, how does this work? Okay, this was a little bit. What is this? I'm kind of curious. Servant streaming Haskell. It's a little old. Oh, interesting. Uh, so I guess this is like a basic streaming module or an iterable streaming monad transformer. Okay. Oh, okay. So we can, if I understand this correctly, and I'm just taking a stab out of semi darkness, is that like, we can step further into the stream, right? We can pull out F. Yeah, we can pull out F, which is like I guess our input for each step, and then we end with an R. So and I think that's typically just like we don't return anything interesting because like what are we returning to? We're returning to probably just the base process. Um, yeah, and we're producing consuming what is probably just this F here. And so return, as you can kind of see it with the data type too. There's no way to continue streaming, right? What a stream is, right? Where you continue peeling back through the sequence of events. There's no way to do this if the case of stream type that we have is return R, right? At that point we are done, and we are just you know leaving whatever is left. Um, and of course, I bet you this is a monad. So it looks like it's a monad. Basically, there's a lot going on here. I just see monad M. No. Okay, sorry, I'm stupid. We're saying it's an ord of that. I can figure this out easily. It is a monad. Yeah. Okay. So it's a monad. It's a monad IO, and a whole bunch of stuff. So, but how would we do this for servant server? I'm curious. Even just like my goal is going to be to try and figure out conceptually how this would work for, say, streaming a video. Um, and I think actually, I feel like servant docs have a thing on streaming. Streaming out of the box. Servant supports streaming. Okay. Yeah. So I don't. Okay. That servant streaming package actually kind of confused me a little bit. I'll say. close off a few of these. Um, Where did we get to there? Okay, yeah. So serving that client that's streaming. Oh, stream body. Well, where does that come from, anyways? Stream body is from servant.api. Okay, so just like the basic package, um, where we find stream body. What is this S? Okay, so it's nice because it's telling us like whatever S is qualified for, and more clearly what is this here? This is from this module, right? So anything here, this S dot stop is from this module, and I can see servant dot types dot source t is a thing called a step T. Okay, so this is defined by servant. So I have no idea what this is. Sounds cool, but maybe that's not even necessary to use another package. If servant builds their own, then I trust that they have done it in a decent way. Oh, and the thing is too, if you're looking at this, um, it wasn't really worth like kind of talking about up front, but I think this actually gives an example. Well, in a very maybe unclear way, I think. No, sorry. Yeah. Okay. Yeah. This. Okay. So I was trying to look at this. This is one whole type definition here, and like so we can just and we can like in the same way as before, we can just combine types, and types are really their own cool interface, and that like we can literally just instead of having this big chunky boy, which is just our get request, you can say get books. So what is get books? Get books is just a type we have. And I think okay, and I think this actually is a great demonstration of like why Haskell is awesome. I have not done servant in 5 years, and I just like I understand it. And the reason why is because like there's nothing really that there's actually this is the craziest part is that there's nothing specific to servant that is awesome. Like servant, it just uses the same tooling, the same tools that are available to other library developers. So if I want to build a library, I can build an awesome library using the exact same tools. I can use data kinds, I can use type families, I can use type operators, whatever I want, and I have full reins for creativity to build a good library. And I think this is twofold. Um, because what that means is I think like if you are if you care about people using your library, you really need to do a good job of having a tutorial for your library, good documentation, all of that. And there's definitely some libraries that in Haskell don't make that a priority. I think there's a new tool called H enforcer or henforcer is more funny to call it. And it's a good tool for like enforcing documentation throughout the code base. And so I think I'd really like to see Haskell start to use that, um, so that it's clear, um, so that it's clear what's how to use the library because like I think there's an assumption that like oh well it's self-documenting, and that's true to an extent. But I think because of the same power that makes Haskell self-documenting, it also allows for a lot more power, just simply right to build stuff. And so when you're doing that, you have the ability um, to to um, to make things more complex. And anytime you're using more power, you probably need to do more documentation. Um, so so yeah, okay. So looking at this, and I just proved that point, and I'll say one more point here. Let's say, for example, like we wanted to change this. Um, yeah, we want to change this. We're not sure what content type we want, so we can actually just say here content type, and then I guess our thing here is going to become a postbooks JSON. We need to eventually pass the argument, but we could also have, for example, now we could easily reuse that same API to make an entirely different API with a separate handler, right? This basically just means give me a new handler. Um, we could say post books text, which is another instance of accept. Um, so yeah, that's that's what's cool about it, right? And this is again all like a really awesome use of all the tools that Haskell has, in terms of servant, and that we can do really awesome stuff like build type safe APIs, which has clear, obvious benefits for security reasons. And we can also say that these are just basic things that you can do, or maybe not basic things. These are just things that exist in Haskell. Um, so Haskell is one of a kind for that reason. Okay, but streaming out of the box. So okay. So these are all. So where's this source IO? I'm honestly just gonna copy paste it first, and I'm just gonna say streamer. And then you can just say add the streamer case. I'm gonna need to add another handler here. Your streamer, and then we'll say streamer is slow. Okay, slow. So we're just doing very simple IO. We're gonna print that we are yeah we're gonna print our source. Sorry, we're gonna print. Print what? We're gonna print. We have one argument here. What's the argument? It looks like, oh, we're gonna capture. Oh, and this is such a good thing to know. So what does this look like, right? We're gonna have slow. Our route is gonna be slow with some number, um, and then that's gonna be our path. So this is basically saying that we have to enforce that the the path here is going to be literally slow, um, or the literal slow, and then any number here is going to be captured and provided as an argument. And again, the tutorial walks us through this a lot quicker, or sorry, slower, and more in depth. But I just also wanted to provide this as a way to um, experience it, experience servant. this is going to be an int, and returns a handler. I'm not sure what it returns actually. I'm very curious what it could return. Oh yeah. Source IO. Okay, so that's also just another type to add here. Uh, New line framing. What is this? Okay, I'll just. And you know what? Honestly, at this point, I'm just gonna import the whole thing because I think I've shown the point, and now it's just about speed. Okay, so lift.io. We're gonna want to import lift.io from control dot monad dot io dot class. This is just the lift.io function. I happen to know that. Again, you can just look that up on Google, or maybe even the Haskell language server will suggest it. And then slow source. I don't know where that comes from. Oh, okay, this is just another function we need. I'm gonna put this here actually. Thread delay. I think thread delay is from concurrent. Um, fast source. Where the heck do I use fast source? Oh, okay. Fair enough. Source T IOB. So this is literally. Okay, so Haskell has told me that the hole here is specifically the source T IOB. Um, and the B is it now knows to be an int. And this is I think like I hope today kind of demonstrates why I think of Haskell as an amazing exploration language as well. Because like even maybe I'm not like clarifying it enough, but like this is awesome what I just did. I just said, hey, I don't know what this is. Um, I have no idea. Like I kind of try to fill in as much information as I possibly can, and then the compiler is either going to tell me like one of two categories. Uh, it is this exactly. It is an exact type that you want, or even maybe that's a little bit more complex than a polymorphic type, or it's have no idea what I'm talking about. And then at that point, I know that I need to look more deeply into the documentation. Um, but I can probably figure out pretty easily where I need to go from there. Um, okay, so I guess that worked. So does that mean if I go nice? What happens if I go here and I say slow 5? Ah, cool. Cool. So okay, awesome. So I've just set up a streaming service in I just set up a streaming service in Servant. Can this just be anything? Slow source. So what? Okay, interesting. What is the types of these? This is so interesting. That was remarkably easy. I've definitely never done that before. Pardon me. Granted, there is obviously a tutorial which I just followed, but like you know that that's not always the easiest thing. Like I guess I'm not really um, too proud of the fact that I was able to do that with like Haskell, because honestly, again, Haskell is just um, it's just very clear what exactly it's supposed to do. It will tell me if I'm doing it wrong. Um, okay, so this is just both int to s dot source t io int, meaning I don't. Well, that's weird. So what are all the actions that we are able to do here? So we can stop. We can throw an error. Or we can do an effect. Oh, okay. So I think so. It looks like whether we stop, like stop is like exit success. So if we our expression returns a stop. Um, we just everything was good. Returns an error. Obviously, it was an error that happened at some point in our at some point going through um, our sequence, our stream, and we can also just skip. So I'm kind of curious, actually, how would I if I want to skip? I'm going to say if m is equal to 2, then I'm going to skip. I think. think I want to do m minus 1. Otherwise, we'll just loop infinitely on on that. And then I want to say I don't even know what make is, but I'm just gonna try it out. Make m minus 1. Let's just see what happens. Okay, yeah, fair enough. Oh, I don't need to do that. I can just say okay. So skip takes a different set of arguments. I was thinking that I had to take an M or an A or whatever the heck. Um, okay, so that worked. And I'm curious now if I go and I stream this again, what's gonna happen? Am I going to skip 2? Oh yeah. So I have it said to run on 80/20. Cool. I've never used that before. Um, but I mean, again, how did I know that this would work? Because like the core structure that I'm dealing with here is all just basic Haskell. We have our head and we have our expression, and here we have kind of a sub expression where we had a where block where we can define specific variables, right? And here we're defining what happens, or yeah, we're defining the definition of delay. So I can even write this a different way. I think it makes it a little bit more clear. It actually uses another language extension. Um, okay. I always realized too late when I'm using Emacs that I could have just done a string replace. Um, Multiple times. And this should also, let me get a little bit fancier with this. Result bin servant. Oh yeah, and I need to add the language extension of lambda case, which doesn't really do anything besides make it pretty. And I like it pretty. Pretty code does matter. I think was even being said in the chat earlier. Voila. There we go. Oh, no, I don't think it's gonna work, but whatever. And I want to say at 80/20. And now I'm going to curl the slow one again. I forget what I changed. Oh yeah, we just made it like a little bit more clear that we are just defining um this thing. So I guess okay, the whole point of this And why it's called delay is because we have this thread delay. And we actually can just kind of put this to 0. Um, and obviously we'll see that this is a lot faster. So it might not. It still might. It might no longer be super clear that we are. Yeah, it's no longer clear that we are streaming. But this is cool because basically what this is saying is like, and I'm imagining now, like, what we have is basically something we could stream a video with. So, and I'll make this up just for the sake of it. But we could say that, you know, we could say that, and I'm curious how servant client works. Like, does like servant client, for example, have like anything where servant client have anything where it helps to kind of re-put together the stream, um, and this is some, again, like I really want to use servant in my overall full stack framework, Jenga, which is basically just built on Obelisk, which if you don't know Haskell means nothing. Um, but yeah. So, anyways, so video stream is basically just a bunch of pixels. So try to remember. I guess it'd be a video stream would be not just so it would not just be one pixel. It wouldn't be a row of pixels. It would not be um a column of pixels, a column of rows of pixels, which makes a matrix of pixels. But it would rather be a um, you know triple embedded thing. So I guess let's just make this up here. I don't know. A pixel is a RGB value with a hex. And I think hex actually has stuff, but I'll just say for now, for the sake of it, that's a pixel for our sake. So we could very easily take this and say this is not a this is not a this is no longer an int, and I guess I'm assuming that I'm confused by the other example we looked at, but I'm assuming here that this int is what we are yielding, and it looks like that we are doing that, right? If I look at even at I can answer this for sure, and if I say yield, I can see that it does correspond like more clearly to that same type. So I guess that this is source T. We went down one step, but basically, right? This is just something which yields this A. So um, yeah, okay. So let's write this. So I guess we got to write fast source as well. Um, S dot from step T make I don't like this, I'll be honest, because I'd rather just look at it like this. So make is applied to X, which okay we call M here. So I guess in my world, where I am writing a new case of this, and that's not valid syntax. You know what? Let me just say it like that. Yeah, I guess I want to do this pixel make frames. Um, and I'm going to say if well, or rather, these are the same thing, but I'm just gonna say that. Um, then I'm gonna say s dot stop. We have sent over all of the frames um, of our video. Um, oh, and I'm gonna need to. Well, you know what? At this point, I'm just going to comment that out, and we will deal with that. This was just for fun. But otherwise, okay, so this is very, very, very simple. So we either are at the end of our frames, or we're not. And if you're familiar with basic Haskell, this feels the same way as thinking about just a normal list. Um, we do recursion for simple lists, and recursion is scary at first, but I think it's the lambda calculus that's probably more scary, and you don't learn lambda calculus unless you do functional programming, or maybe you can, but you have to learn it when you do functional programming rather. So anyways, here we're just going to say otherwise. We're going to yield. We're going to yield a frame. So I think, and you know what, this is actually not even the best way to think about this, because I'd rather think about it like this. I'd rather write my function like this, where I'd say we either have make that, or we have this pattern. Right? We have two patterns that we know we can have. We either have um, you know a at least one element in the list, or we have an empty list. Right? Those two things are total. We know that we either have an empty list or we have not an empty list. And right, just very simply, x and not x is always total. So that's exactly what I said, is that we have an empty list and a not empty list. And a not empty list, which is said in a more useful way, is that we have at least one element in that list that we can pull from this list. So we're going to say here that I yield the first element of that list. And I guess, it looks like this make is probably important to step t, because I'm going to look at this now because this feels less scary. So basically, oh, okay, so not super interesting, I guess. Um, it still gives me a bit of a mind bender. I'll be honest with you, but so I'm trying to think of how to read this. So I guess, but okay, here's the thing: is we can easily say, what can we say very quickly? The easiest way to figure this out is to just ask. Okay, so it's an A to a step T M A. And so in the previous example, the a would have been the int, um, whereas now in this example, this is going to change into um, a single frame, um, or a video, depending on what we want to do. We're not going to yield a whole video, right? We're gonna pull from a stream, which is the video, and we're gonna yield probably a single frame. I guess we could, in theory, do by pixel. I never thought about that, and I don't know if I'd want to do that, but like I guess you could. I don't know. You could if you want to get that granular, you could. I'm curious if anyone knows if that would make sense to do, but um, world is your oyster, I suppose. At least with Haskell. So, okay, I am going to remove that. I no longer need it. That no longer serves my thinking. And I'm going to say that this is, I believe, I'm going to take a stab and say this is a video, right? This is just a video. The triple frame is a video. Um, I guess, heck, we could even say this. Um, pixel row, type pixel row equals a list of pixel. A type of frame is a list of pixels, or similarly a list of pixel row, whatever you prefer. And then a video is a list of frames. So I'm going to use that just because it makes it more clear, like what I'm doing. Remsuda on the stream is probably very happy that I'm thinking in domain modeling, his favorite concept. And so, yeah. Okay, so we have, and I think that makes sense. Like that, like even if you don't know Haskell types, I think that's actually pretty easy to see. Like I can see how you've constructed a video from a set of pixels. So we are ready to take over the world with AI and training, I suppose. Now, I think this would just be a step T. Oh, I'm going to change this. We have a video. Step T M frame. So we're going to yield a frame on every single step. And I think source T, I'm going to guess I'm not sure what source T does for us exactly. It's not clear. But I mean, I guess if we go back to that example, I don't know. I'm not. I'm honestly not quite sure because we can just say, I guess I can just, yeah. That's interesting. I don't know. Like, maybe maybe. Yeah, actually, you know what? I think. Okay, so in my head, I am assuming that the monad here is the same as the monad here is the same as the monad here is the same as the monad here. And I am using handler as that monad, where handler is just basically exception handling. Um, but I don't know if I actually need to do that. Oh wait. Did I forget that piece? Because we also are. I don't. You know what? I don't know. I actually no. Sorry. We are still using the same servant monad. I was confused for a second, but like, what's funny too is that we have this monad, which I seem to be using just fine across my entire application. And I could test this. I could easily just say this. Check what happens. Will this complain? I don't know. You know what? Maybe I'll look into that later because I'm now curious. But ultimately, we have this other data. We're kind of returning it as if it's a first class value, like the actual functionality that exists within our with streaming, right? Like this is just an action. So like for example, like we can have we can return I could do something like this where I say I'm going to normally like very normal function. I'm going to say print or print hello, and I can also do something where I can say pure of print hello, and then what do I have? I have a IO of an IO action. So how would I use this? I would go along and I would say, um, you know, uh, run F. Right, F is going to provide something. I'm going to call it um, printer, and then I can just say printer, right? And this actually all type checks. This all works. This all makes complete sense. More importantly than anything else, it doesn't matter that we could represent it if it doesn't make any sense. It completely makes sense. But it's cool to note that like you cannot do this in other languages. Um, this is an action, right? What does this mean? We can return an action, and like while we're not really doing anything interesting here, I can actually do something more interesting, which is say, maybe I don't know. I get the line. I say x. I say get line. I say if x is equal to hello, then print hello. Else, and I don't need these brackets, but I'll just say it for the heck of it. And so now I can just say this actually. Right, so I can just wrap that whole thing. I can even wrap the if statement if I want um, in a pure thing, right? So I can wrap um, this this function. So now what I've done at this point, I haven't like when I get to this line and I execute this line, I have not printed anything. I have instead created an action for the future, right? So in the future, I can do a million things in the middle here, and then finally at the end, I can say, oh, by the way, hello or hey there, and so like that's what we mean when we say something like this, where an IO which is our kind of core monad, because like otherwise we're just creating heat on our computer. We're going to do something with input output eventually in our program, but we can just return a whole nother program, right? I could literally like I could even take this and I could say pure main, and main is a literal function. It is the entire program that we have already developed here, and that's valid. That's completely valid code, and um, yeah, so if there's a way that it makes sense for me to model something using that kind of theory, then I can go ahead and do it. And so here it looks like that's exactly what they've done, and that they have said you can return a book, you can return a list of books, and you can also return a stream, which is pretty extreme, if I may make a awful joke. And yeah, so the point being here, and well, I think that's well said or well explained, thoroughly explained. Um, we now have an action that are returning, and I guess that action is going to be somehow taken by the internals of servant and is going to be handled. It's going to be run at the appropriate time. Right? If this all matches, we are going to um, you know, run our application and then perform, you know, give back the data that the user wants, which is not just a simple data type, but rather a stream. And I guess Servant just handles that for us, um, which is really cool. So, anyways, to finish this off, we could say make x's. Or we can say, in the case that we are at the end of our video, we can just stop. So see if this compiles. Oh yeah, s.stat. 77 and 81. And so this should work. This should compile. Oh yeah, right. Slow source. Now I want to say, instead of using slow source, use video stream. Except, instead of, I mean, I'm not going to really change anything about this int for now. I'm still going to capture a number. It's going to do nothing at this point. And so at this point, I don't even need a pattern match on it or give it a name. I'm now just going to give it instead a chunk of videos. So let's say this is our video. Right, this would be our frames. And then inside our frames, we have lists of pixels. So yeah, what can we do here? Pixel 1, 2, 3, pixel 4, 5, 6. We're gonna say, I'm so lost on where we are. Okay, well that's kind of nice. Yeah, okay. So the second row of the first frame is what we are writing here. And 10, 11, 12, pixel, 13, 14, 15, and for some reason they're I guess square frames, which kind of makes sense ish. 17, 18, 19, 20, 21, 22, 23. Wait, what am I doing? I don't need those. 24. Because I'm just constructing the type. Let me check if this works. Oh yeah, I guess change it that way. That'll be our design decision. Right. Oh yeah, because okay. We haven't changed this, so this is still confused on what the heck we are trying to say. So I'm gonna comment that out. Right, we still need to fix these types. Not that we need to fix that one I just deleted, but might as well make it more clear what we're doing. Okay, 59. Right, and I am returning a frame, not an int. And so it knew that. It literally said there, hey, you actually gave me a frame, but you're telling me to expect an int. And that's because we haven't updated it yet. So that was pretty nice, and this is going to compile. I lie. Oh, and then the last piece is that this is looking like the last thing is that I need to update the type here because it's still expecting. Yeah. So it gives us okay. So like sometimes this type, so sometimes this error is a little bit like chaotic. But if that's the case, you always have this nice little description up here, which usually comes along with it. Um, and it's a lot more clear on what the issue is. So this is saying cannot match type pixel with int. Um, and I mean, this is going to happen when we get into like type level programming. You know, I wouldn't recommend it for like an actual beginner friendly, library. But I think this is a cool library more than a beginner friendly library. It just so happens that everyone thinks it's the coolest thing, so they start on Haskell to use this, and then you know. Oh, okay, yeah, and I need to. So just like before, I needed to um, give JSON instances to Pixel. I'm also actually going to move this all up here, just so I keep all my types in one place. And I am going to say deriving generic. This one is interesting because it's a lot less clear how it becomes how it would become a JSON type. But you know what the thing is, like we don't actually need to care because at least in this context, because we have round tripping of pixel, right? So in any case where you say JSON, from JSON and to JSON, and just like take the default instances, it will always round trip perfectly, right? No matter what this is, right? I could literally put an A there, um, and as long as that thing has an instance of generic, it will properly convert it to and from a million times over, which is pretty nice, just out of the box. Okay. And I think we need to pass the port. Um, nice. So we just streamed a video. Not really. We haven't actually gotten a video yet. Um, but honestly, you know what? I'm so curious at this point. I'm like we're so close to it, and I think it's like the funny thing about Haskell is like the theory, like the type of challenge that you might use Haskell for or whatever, or you might like no, if you take a challenge and someone says like, oh, like that's really hard to do or whatever, um, just learning the theory of it of Haskell probably gets you to 99% of the way there. So now I'm curious, how could I actually get how can I get like a real video stream here, right? Because all I have to do is I have to find a real video, and then I have to chop it up, and then I have a video stream. Maybe it's not going to be using pickles, but um, yeah. So I don't know how to do this off the top of my head, and I've never even thought of this concept. So honestly, I am just going to say, sure. Um, how would I convert a video to a list like structure in Haskell, e.g., you know, okay, fair enough. Oh, and I guess too, it was saying I could use this, which allows me to stream juicy pixels a little bit. So juicy pixels, I didn't know that was a type. And I guess we do have to have a way to handle this in terms of the mime types. Okay. Ultimately I'm just curious to see um, what this would look like, and I want to get off at the same time. So, which I need to eat at some point. But I guess okay. So this is cool. So I mean, yeah, like I guess what is this doing? This is pro video, parse probe result. Okay, bytes to frame. Um, I mean, I'm definitely not again doing it in a very efficient way, um, by any stretch of the imagination. But I am curious to like kind of actually do this as a real thing. And maybe from that perspective, I shouldn't be trying to vibe code anything like this. I mean, it makes sense that we're using FMmpeg or FF Pro as well, which is just really FMmpeg. Um, but the data structure probably sucks. So I mean, like we're we're kind of squeezing it into a data structure. This is the really the issue is probably that just we're streaming it into into a data structure, when probably we could just do it without like we could just stream. That's why there's no reason, right? We're not processing anything about this video. We're just simply saying, yeah. And actually, we probably did a more complicated thing than was even what even needed to be done. So yeah, right. Get a chunk. Um, okay, so I guess we're just using metadata about the video, or the frame size. Where do we get the frame size though? I'm curious. I'm gonna accept this and then I'm gonna go into this. So okay, well that's sketchy to say the least. No, don't fucking. Hmm. So I guess we're just trying to figure out how to get a chunk hget, and then hget is just basically from a handle. And yeah, just the number of bytes to read. So I'm even wondering, like, could we not? Hmm. Why would we not want to? Why would we not want to set the um, set the value passed to hget as one, right? Not just extreme one thing at a time. I guess it really just like maybe there's a I could see there being a reason based on just like how much I don't know like you don't want to send um perhaps you don't want to send too small a packet size, but right performance just it's not it doesn't make sense. Um, I guess okay. Okay. Well, I guess. So I guess that's interesting. Like it really just yeah. Just give me honestly. Just give me the simplest invitation. Um. I guess they're all simple enough. Um. But yeah, I guess the point being that we can just continuously take any length of a chunk of a byte string and continue sending it over and then rebinding it together on the other end. Oh, okay, and it can do octet stream, which is I guess even quicker. We don't need to convert to JSON um, if we can keep it at an octet stream. Wait, did it overwrite what I did? Stream file. Oh, okay. I just video stream. Okay. I'm not sure. Oh. So I don't care. Basically, it's not finding static which I don't really care about, at least at this moment. So I'm just going to remove this, and it's just going to find FMmpeg, or it won't. I don't really care. And I guess I need to remove that. And then do we have it in our Cabal file? It's a great. It is a great little tool for making sure that your program is able to find the executables that it needs. We'll probably actually see it fail at runtime if it cannot find the appropriate um, if it cannot find the appropriate FMmpeg. Stream file video. Oh, I need to pass it a path. I don't want to do that. Let's say instead, I'm I'd rather just hard code where I have a video. Okay, this works. Um, this is something I built with another project. I'm trying to. It's basically an AI project. It's not going very well. Okay, I don't know why it's doing that. Okay. I'm just gonna say the path is what was it? It was documents, simple Haskell recordings, clips working output. Cat walking through forest, MP4. Right. Let path equal. Okay. So I'm gonna rerun this. I guess we're gonna put it on port 8202. That worked for our first example. Now I want to say video. I'm gonna give it some thing I don't. Yeah. So see, it cannot find FMMPEG. So I mean, all I really need to do here is I just need to say that let's ensure FMMPEG is in path. I can also make sure that this is done properly through Nix and through static which. There's no possible way that that could go wrong. Um, Nix build. Video. So we can see that we are streaming the video now. We obviously need something that's going to consume that, and we could get into like servant client, but I think at this point, I really need to bounce myself. But yeah, we have successfully streamed a cat in the forest in servant, and we have not done that in multiple years. But we naturally came back to it. It was easy. Um, yeah, I cannot actually believe how much we got done. I am like blown away. So, um, I'm gonna post this on the. I'm gonna post this on GitHub. Um, and yeah, I'm gonna post this on GitHub, and then I'm gonna do that while we're on stream, just so I don't forget because I am very forgetful. And while I am still on stream, and if there's any questions and all that, let's see. Actually, let me put on. Let's call it service streaming example. Um, Voila. Um, and now I want to say that this is let's get push. I'm gonna need to figure this out. What the heck? Okay. And yeah, so now this should be up there. Cool. So feel free to go through that, check out the source code. Um, you know, we built this really quickly. But we built a pretty awesome application, honestly. So we can really just swap out whatever data type we are using, and it's actually you know exactly the same thing, right? We've seen how to stream. It's really simple. I mean, what language are you gonna write that little code to do streaming? Like boilerplate is already double that in any other language. Um, it's not about being pretty, but being pretty definitely does help. You know. So so yeah. Thanks for joining. I'm gonna end this stream there, but it's now a good time to say we have a Discord where you know y'all can join us, uh, and um, basically um, yeah. I mean, we're just always talking about Haskell, and trying to learn from each other. We run a community called typify.dev. So typify.dev is a really it's a wide ranging platform. Um, the way that we make money is by helping you get a job, but there's also a lot of things that we do there that is just for free. For example, we have coding challenges, which also do help you get a job, but those are for free. Everything is for free on the entire platform, and we are just obsessed with Haskell. We are obsessed with programming in general, and it's our obsession with programming and engineering in general that has led to our obsession with Haskell. Um, so, yeah, if you have any feedback for us, we are always, you know, curious and ready to listen. Um, and yeah, so thanks so much, and have a good night, everyone.